Hey guys, today we're going to be learning about earthquakes. Some of the essential questions are: how does stress in the crust change Earth's surface? Where are faults usually found and why do they even form? What land features result from the forces of plate movement? How does the energy of an earthquake travel through Earth? What are the scales used to measure the strength of an earthquake? And lastly, how do scientists locate the epicenter of an earthquake? The beginning of the PowerPoint discusses forces within Earth's crust. These forces then in turn will eventually release pressure and turn into an earthquake. So that's why we like to start here. Stress is defined as a force that acts on rock to change its shape or volume. The three types of stress acting on rock layers are tension, compression, and shearing. I don't know if you noticed yet, but we've already discussed the three types, the plate boundaries. Each plate boundary actually will give a different kind of stress. I don't know if you guys can tell which stress is going to go with which type of plate boundary, but I'll tell you now. And you're more than welcome again to write anything I'm saying down that might not actually be in the notes itself. Tension, you can see, is pulling something apart. I always like to say, think of it like if you have tension between you and a friend, what happens? You typically maybe don't talk to that person for a while. As a reminder that tension is a pulling apart, which then in turn would be what type of plate boundary, and that would be divergent, right? Divergent is when you have the plates separating. So tension and divergent boundaries go together. The next one is compression, and that's pretty easy to remember because when something's being compressed, it's being pushed together. So of course that would be a convergent boundary. Shearing is the last one and the one most commonly confused, so it's just one that I want to make sure to let you know about. Shearing is when you have your rocks going in two opposite directions. You're going to get sometimes pretty nasty earthquakes from this because these are your transform boundaries. A lot of times the rock will get kind of caught on another piece, and eventually when that stress is released is when you have these major earthquakes along fault lines. This I gave it to you again, just in case maybe you didn't write it down. You can always screenshot this or write it down now. Before stress, you can see what the land looks like, and then after a convergent boundary is taking place, you have a compression type stress, creating mountain ranges many times. Divergent boundaries, we learned, is the separating of Earth, and you can see that it's actually pulling it apart. And shearing is the last type of stress. Again, that is going to be for your transform boundaries. Faults and folds. A few things you need to understand vocabulary-wise is the difference between a fault and a fold. A fault line is a break in rock layer of the crust where the rock surface slips past each other. Fault lines occur at transform boundaries. Folds are forces on the rock layer, and it's when the rock is not moving as fast or is not strong enough to break or snap the rock. So instead it simply bends the rock layer. It's actually pretty cool to look at. And you guys can see a picture here of a fold versus a fault line. And this again is a fold right here. Depends on, so there's three, again, different types of stress. Depending on the type of stress applied to the rock will depend on what occurs, what type of fault. So the first one we'll go over is tension. And tension is going to cause a normal type of fault. Tension again is at a divergent boundary. And sometimes what I like to do, you can see I drew a little shoe, and you were like, okay, why is that there? So I like to explain these walls in different ways. This right here is your foot wall. The reason I drew a shoe is because the foot wall looks like a shoe. The hanging wall, on the other hand, is the one in front, and it doesn't look like a shoe. So that's my best shoe that I could draw. Almost looks like a skate, but the foot wall is always going to look like a shoe. Hopefully you'll remember this image in your head. If your foot wall is hanging above your hanging wall, so your hanging wall is hanging down, then that means you're looking at a normal fault, and a normal fault comes from a divergent boundary. If your hanging wall is hanging above the foot wall, like this one here, and your foot wall, right, that's a shoe, is below your hanging wall, that comes from a compression type stress a convergent boundary, and it gives you a reverse fault. And you do have to know all three and how they correlate. The last one, shearing. Shearing is going to create what we call a strike-slip lateral fault. Lateral faults are going to be pretty easy to identify, I think. The most commonly ones that are confused are these two. This one, because you already know that a transform boundary creates shearing, hopefully, or you'll learn that. You'll remember that transform boundary, they're moving in opposing directions like this, so it might help a little bit on this one, but these two, a lot of students will get confused. So normal faults come from tension. Tension is a stress that is at a divergent boundary. Compression is a stress that's going to be at a convergent boundary, and compression will give you a reverse fault. Shearing is going to be the stress created from a transform boundary, and it will give you a strike-slip lateral fault, like this one here. The last one not discussed yet is a thrust fault, causing a major compressional force pushing the hanging wall is up front, completely on top of the foot wall. And this gives you an image of what that looks like right here. This is something I drew out years ago when students were struggling to determine which is the hanging wall and which is the foot wall. I do feel though that the image above with the image before with the shoe is a little bit easier to understand than this one. These are the land features that may occur at particular types of faults. The first one is when you have two normal faults pushing a block of rock upward. That can cause mountain ranges. Also, when you have two normal faults cutting through a block of rock, fault movement may push up a rift valley. A few more vocabulary terms that you need to know that are caused by compression type forces are anticline and syncline. Anticline is, and you guys can see these labeled here, anticline is when you have the rock bending upward in an arch, so anticline like an arch. Syncline is when the rock is bending downward. Again, this is when fault lines are not forming because it's not moving fast enough to really break through the rock, but instead it's just bending that rock, and you guys can see that here. This is the name that fault exercise where you have to be able to look at it. I won't have the shoe drawn on there, so you'll just have to be able to look at it and know what type of fault it is based on what I'm showing you. I drew the shoe as a reminder that that is the foot wall and the hanging wall is over here. If the hanging wall is hanging below the foot wall, I said that that's going to be a normal type of fault caused by a divergent boundary and also caused by tension, the stress called tension. This next one is a reverse fault. Your foot wall is below your hanging wall, so your hanging wall is now being pushed up. That's reverse by a convergent boundary and by compression. This last one not labeled is going to be a strike-slip lateral fault line. It's caused by shearing, so the stress shearing, and it is a transform boundary. Once the stress is released, an earthquake takes place. An earthquake is a shaking and trembling that results from the sudden movement of the part of Earth's crust. Similar to ripples from a pebble in a pond, usually occurs along a fault line. More than 1 million occur per year on the planet. Entire fault will not move all at the same time. Energy is released at different places at any one time. There's some terms you need to know that go with earthquakes. The first is a focus. The focus is the point underground where the release of stress is located. The epicenter is the point on the Earth's surface that is directly above the focus. This is where most of the damage will occur. Aftershocks for an earthquake occur after the larger earthquake in the same area and can also be pretty bad. Sometimes with major earthquakes, aftershocks can also be very bad. Liquefaction is when the earthquake's violent shaking suddenly turns loose soft soil into a liquid-like slurry, and that can take down homes and do a lot of damage as well. Seismic waves carry energy from the earthquake away from the focus. There's different types of waves that you're going to learn about, P, S, and L waves. The P waves are your primary waves. They're the fastest moving of all the waves. They're able to travel through solid, liquid, and gas. In terms of how they move, they have a push-pull type of wave. Secondary waves, or S waves, are second to arrive. They're able to travel through solid but not liquid or gas. They're S-shaped in terms of movement. Rock particles move at right angles to the direction of the wave. Surface waves, or L waves, are the slowest moving of the waves. They travel across the surface of Earth. They originate on the Earth's surface and cause the most damage out of all the waves. This gives you an image of how different types of waves are going to move. These are your P waves, and they have the compression and expansion. And the expansion is called rarefaction. S waves have your S-type movement. You have crest and trough with these. And your surface waves, or L waves, have more of a rolling feature. Your P waves, again, travel through solid and liquid. P waves arrive first, and then comes S waves. S waves reflect off of a liquid outer core. This just goes over a couple practice questions. First, most earthquakes occur along faults. Seismic waves move outward from the focus, which usually is deep underground. The smaller magnitude quakes that follow a major earthquake are called aftershocks. At least 3 seismograph stations are needed to locate the epicenter of an earthquake, and S waves do not travel through the outer core because it is a liquid. Next, we're going to discuss the scales that they use to determine the intensity of an earthquake. There's 3 major scales: the Richter scale, Mercalli scale, and the moment magnitude scale. The Richter scale is the one you probably have heard of before. That rates the overall magnitude of the earthquake. The Mercalli scale rates earthquakes according to the level of damage at a given place. And the moment magnitude scale is a rating system that estimates the total energy released by an earthquake. The Richter scale is the most commonly used scale. As you move up a number on the Richter scale, it's a magnitude 10 times greater than the previous number. So some people think the jump between maybe a 5 and a 6 is not huge, but it really is when your magnitude is 10 times greater. In terms of looking at the numbers, you can see that a lot of them leading up to about 5, you either can't feel it or it's going to be really minor. It's not until you get to the 6, 7, 8, and above where it becomes very damaging. A seismograph is a device used to detect and measure the intensity of an earthquake. A record of an earthquake is a seismogram. The Mercalli scale, which you're going to be practicing on Friday, rates earthquakes according to the level of damage at a given place, and we use Roman numerals to rank those values. What we're going to be doing on Friday is having scenario cards. After you read the scenario card, you're supposed to look at the Mercalli scale and determine, based on that scenario card, what Roman numeral it should get. Tsunamis. Tsunamis are what we call a tidal wave. They occur when a large water wave is caused by an undersea earthquake. When an earthquake jolts the ocean floor, plate movement causes the ocean floor to rise slightly and push water out of its way. It clearly has been very damaging in the past, and you guys, I'm sure, have heard about more common ones that have occurred not too long ago, like the one in Japan. Another few questions. It says, most of the destruction during an earthquake is caused by what type of wave? And that's surface waves. Seismologists use the Richter scale to compare the magnitude of earthquakes. The slowest seismic waves are surface waves. Primary waves arrive at a seismograph station first. Scientists use the triangulation method to locate an earthquake's epicenter. And when the buildup of stress in Earth's crust is so great that rocks reach their elastic limit, an earthquake will occur. And that's it. If you guys have any questions, please let me know. And if you are good to go, you need to move on into the practice now.